welcome back to this section of the course where we will be solving trigonometric equations with angles measured in radians. So, there we will look at three in-depth examples, the first of which is this equation. We have to solve 4 cos theta equal to 2 within this range of 0 to 2 pi, which is from 0 to 360, or rather in a full circle. Okay, so since we first thing I always do, I look at this the equation that we've been given, and this angle is theta. So there's a single theta here. It's not multiple of theta, so we do not need to change this range. So we leave it as it is. Okay, so we go and we can then start solving our equation. Once we divide both sides by 4, we'll have cos of theta equals to a half, and we can take cos inverse of a half. Make sure your calculator is in radians because our range, or rather domain, of our angle is in radians. So we will get the angle theta at pi over 3. Theta is equal to pi over 3. But just before you think the work is finished, you must consider the full range. And if we consider the graph of cosine, we will notice that this angle is also repeated at pi or 2 pi minus the angle. So however much we go forward from 0, we come back from 2 to pi here. So this section of the graph, which has a height of a half, is also uh, the angle is repeated at this point here, 2 pi minus however much we went forward from 0. So you do have to subtract pi over 3 from 2 pi to get the alternate angle. Now that's 5 pi over 3. If you don't like to use the graph of a cosine curve, you can draw yourself a unit circle and consider this triangle here, where actually the angle was pi over 3. So the the cos of any angle is measuring the length of this x value, where the radius of this circle is 1. This is called unit circle. So this this x value here is the same in this top triangle as it is in this bottom triangle here. So you can see that that's why we take 0 to be equivalent to 2 pi, and we say if I turn anti-clockwise, I'll end up with pi over 3, and if I turn clockwise here, so I subtract pi over 3 uh, from 2 pi, I end up with this angle here, which is 5 pi over 3. Okay, so that is the two answers for that question. So in this next example, we've been given the equation of 17 cos plus 3 sine square equals to 13. And we look at the domain of values. It's between 0 to 2 pi, and the cos and sine both are in terms of single theta, so that's fine. The only problem is that we can solve equations when they are either both in sine or both in cos. So we need to turn this sine square into cos somehow. We look at the identity in the top right corner there. If you remember, sine square is simply 1 minus cos square, so we can replace that there into the in that equation and multiply out the brackets. we end up with 17 cos plus 3 minus 3 cos square equals to 13. We can either move everything to the right of the equation or to the left so that we get a quadratic that's equal to 0. So in our case, we could say we've subtracted everything from the left and move them to the right, and then flip the equation, put it equal to 0. Now you can, if you find this too difficult to handle, it's basically 3c squared minus 17c plus 10. Uh, you can either use your calculator uh, to give you the answers, or you can use the quadratic formula. In either case, you will end up with two answers, one of which is we have to throw away because theta will never be more or less than 1. So it will not be more than 1 or less than negative 1. So its absolute value is bounded by 1. That's what I meant to say. Therefore, we will discard this answer here, and we take cos inverse of 2/3. Make sure you calculate this in radians, and the inverse cos of 2/3 in radians will tell us it's 0.84. Now, just like previous example, once again with cos is repeated at theta and 2 pi minus theta. So the alternate answer is 2 pi minus this angle that we found, which will tell you that's 5.44. And that concludes this example. As I said, we can discard the other answer. So in this next question, next example, we have sine of 3 theta equal to this ratio. Now, this is where it's important. You look at what's in front of the sine, it has a multiple of theta. Therefore, within this range, we have to adjust our range here, uh, and we multiply theta by 3. So 0 times by 3 is still 0, but 2 pi times by 3 will tell you it will go to 6 pi. So basically we have to, once we take sine inverse of square root of 3 over 2, we have to go ahead and find more and more answers within the range that we've been given. So first we take sine inverse of square root of 3 over 2, and that will give you pi over 3, right? So we're not going to divide by 3 at the minute. This is the most common mistake that I've seen. Students, as soon as they finish, they think they can finish this problem quickly by dividing by 3 to find theta. Let's leave 3 theta as it is and go and find other alternate answers. We know that for sine is repeated at the angle of pi minus pi over 3. So for the very first two principal answers are pi over 3, and this 2 pi over 3 was driven from the fact that sine of pi minus theta is the same as sine of theta. Okay, so we took our answer here and we said we need to say pi minus pi over 3, and basically so that's 3 over 3 pi minus 1/3 of a pi, which left us with 2/3 of the pi. Now that it only gives us the first two principal values. We can add 2 pi to each and every one of these. So adding 2 pi to this answer here, we're going to add 2 pi to that, and add 2 pi to that, to 2 pi over 3 again. So, and we repeat this process one more time. We'll have 7 pi over 3, 8 pi over 3. We repeat this process one more time because I know for a fact that all these fractions are less than 6 pi. You can check for yourself. 14 over 3 is still less than 6. So, but as soon as we add another 2 pi here, 2 pi, if we mm, give it a denominator of 3, we multiply it by 3, so that's the same as 6 pi over 3. So if I add another 6 pi over 3 to that, to 13, I will have 19 over 3, which is more than 6 pi. So these are within the all these six answers are within the range that we were asked to find. So now this is the stage that you can divide all these answers by 3. So all the denominators will turn into a ninth, in other words. So this is these are our final answers. In the exam, you do need to be accurate and quick and do these calculations, uh, perform these calculations accurately and perfectly. Right. So, just before I conclude this unit of work, I should remind you the unit circle here. You could have also used that as the sign values are associated with the uh, y value of this triangle. So the y value, if I draw it in a different color, would have been uh, this purple line here for this angle, and in this acute angle pi over 3, and it's also the same on the left hand side of the triangle. So these two purple lines have exactly the same height, so the angle over here would have been pi, uh, subtracting pi over 3 from it, which gave us 2 pi over 3. Okay, so if your acute angle is positive, that's what you do. If your acute angle was negative, you would have flipped down here, and the flip side of that would have been if our theta is basically would have been a negative pi over 3, we would have taken still we applied the same formula, and we take pi and subtract a negative pi over 3. That would mean that we would have to add the pi over 3, and that would give you this angle over here. Okay, so with that, I leave you to practice questions in the exercises, and without practice, your work is not done as far as uh, examinations concerned. You do need to get a lot of practice.